Hello guys, welcome back to the channel. So in today's video we are solving another LeetCode problem, that is 3097, shortest subarray with or at least k second. But before jumping into the solution, I would highly recommend you should read the problem statement on your own and give at least 15 to 30 minutes to this problem. So let's get right into it. What problem is asking that you are given nums, that is 1 comma 2 comma 3 and k is equals to 2, and what you need to do is you need to return the length of shortest special subarray. And what does that special means? So if we have some subarray and if we do or of all the elements that are present in that subarray, the result should be at least k. So in the condition wise, what does it mean? Greater than equal to k. So let me repeat it. What does a special subarray means? If we do the or of all the elements and the result is greater than equal to k, then this means that it is a special subarray. And shortest means which the shortest subarray that is special, basically that satisfy this condition, is the shortest special subarray. So let's take example. So we can have this subarray, we can have this, we can have this, we can have independent also, 1 2 3. Yeah, so if we do the or of all the numbers that are present, what we'll have? 6 is greater than k is 2 in such case. But is it small in length? I think so not. And if we have 1 comma 2, this is 1 comma 2, we'll have 3. Is it special? It is special, but it does it is it the smallest? Does it fulfill that? Is it the smallest? Yeah, so coming to this 2 comma 3, 1 0 1 1, and what it gives, 1 0 1, it is 5. It is special, but is it smallest? I think so not. Is it special? 1, no. 2 is special and lengthwise it's 1. 3 is special, lengthwise it's 1. So we'll return 1. We don't need to return the subarray, we just need to return the length. So just return the 1 in this case. I hope this much is clear what problem is asking. And I kind of discussed brute force also. You can make all the subarrays and check if they are special, and if they are special, store it somewhere and just see which one is the minimum, just return that. But we can do something better. If we know that this is special, then what we can do is we can just decrease the size and see if this subarray is also special. If this is true, then we should check for this also. So if you see, this is a window, then we are decreasing that window size, so it does point to something. It is sliding window algorithm we can do. I hope this much is clear. Basically it's kind of same thing. We are generating subarrays, but instead of independently generating, we just generate in that same thing. If we found this, we'll generate other subarrays also and we'll check if they have the special status. So yeah, algorithm wise, how it would be looking, it would, what we do is we'll increase the size of window till it is less than k. Not less than k, the or of all the element is less than k. Till then, basically till then it doesn't have special status. Till then we'll increase the window. When it will have special status, when it will have special status, when it will have special status, we'll do what we'll do. We'll store that length, and we need to decrease the size of the window. We'll decrease the size of window, and also because this OR is already calculated, result of all the OR operation we did, we need to remove that part also. So we'll update the OR result, and we'll keep on doing it when till we have special status, we'll keep on doing it till we have special status, and we'll have our result. This is what algo would be looking. Let's discuss the coding part, and we'll discuss more things over there. So let's not focus on update, I'll discuss about it also. So what we are doing basically, if you see, we we pick that number, we check over here if it is greater than equal to k, if the OR is greater than equal to k, and we are keep on increasing the window, and if it is greater than equal to k, we'll have that length stored, and we'll update the length and update the value of OR. This is what basically we are doing. Now how we are updating over here, adding that value, doing that OR, and how we are removing that OR, let's see. Basically, let's all first discuss this. Not first discuss this, let's first discuss the update, then we'll do bits to int. Basically, bits to int is quite explanatory, because if you see over here, we have a vector of int, and it is of size 32, because we are storing the bits, and what we are doing, in order to convert it back to a number, we made this function. So let's first discuss about this, because this is responsible for updating this bit count. So if you see, if you have one looks like this, one is one, or binary wise it looks like let's take a two looks like this. So what we are doing, we are shifting the bit, but let and then we do a and if it is a 1, it will be executed, and we add the delta. What delta over here means is, we'll just put a 1 over here. As you see, previously it was 0, now it went to 1, we'll add 1. If you see, when we add something, we are sending a 1. When we remove, we are sending a -1, because it's basic why I'm explaining. Now when I is 0, 0 and 1, 0 and 1 is 0, this will not be executed. Now I is 1, bit is shifted 1, so 1 and 1 will be done, and we have a 1, and this will be executed, and I is 1 in this case. So this, if you see, it was 0, now it is updated to 1. That's how it is working, it is updating. And yeah, and after we have something like this in this vector, we need to get it back converted to a number. That's what we are doing. So we have a result. If you see over here, we have a result. That result is 0, and 0 is 0 in binary. And if we have something like this, this is our first thing, I is 0, we just shift a bit to no place. 1 means 1, because this doesn't mean anything. So 0 or 1 is 1. Then again I is 1, and we shifted one place, so this is what we get. So what we do or we have 1 1, we have a 3. Basically it's get converted back. This is what we are doing. And why we are taking 32? Because that is the size of int. That is the size of int 32. I hope this much is clear what we are doing. Let's take a small example just to dry run this, so that we'll have a better understanding. Do-do-do-do. Yeah, let's take a small test case, because it will be a quite a thing if I just go over a longer test case. Well, the video will be much longer. This part you should do it, but just for better understanding, start is 0, end is 0, bits count is like this, all the places it's 0 0 0 0, bit counts, and yeah, start and end is 0, bit count, and yeah, we'll begin. Result is also there, int max. We do a update and we get to a, because if you see, we'll send a number. What we are sending, we are at the 0th, end is on 0, we are sending 1. 1 is checked. If it has a set bit, we have a set bit. What delta is sent, delta is 1. So what we do, we update this to 1. Okay, and now we'll check if this thing, if after converting this back to a number 1, because 1 binary 1 1 same, so is it greater than k? Greater than, no, it's not. We'll increase the end is 1. And if you see start is less than end, basically it's kind of a no brainer. Start can get till here, can't get outside of it. Yeah, now end is on 1. Now we are sending, what we are sending, end is on 1, we are sending 2, and binary wise 2 look like this. So for I is equals to 0, 0 and 1 will fetch 0. This will not be executed. I is now 1. Now this is shifted, 1 and 1 is 1. It will be executed, and we'll add 1 over here because we send a 1. Yeah, this much is clear. Now this condition will be triggered. We'll first basically will convert this to a number, so our bits to int will executed. It got executed in this case also, but I didn't show it because we can show it better in this case. Now we have result 0. Now here you see I is 0. When I is 0, bit is not shifted. If you see, this is what we have written, I is 0, no bit is shifted. We did a or 1. Now result is 1. Again I is 1, this time it is shifted. How much is it shifted? Now this is 1 0, and we do a or. Now we have 1 1, we have a 3. Yeah, and is the 3 greater than equal to 2? Yeah, it is greater than 2. We get inside, we'll just check. If you see, end is 1, start is 0 plus 1, and result is int max. So you know what to do. We update this to 2. Okay, now we'll again update it because we had this length. It's special, it is special. Now we should check for this, and what we are doing, we are updating, we are making that start to 1, and also same time updating it. And you see, I am sending that number, this number, and also -1. So what will happen over there is, we are sending 1, so this 1 and 1 will do that thing, and this, there is 1 already and -1, so this will be a 0. So now it's again back to a 0. Okay, again we'll check. Again we'll check. Again we'll check. And this, and what is this converted to? 1 0 and 1 0 is 2, and 2 is equals to 2. 2 is equals to 2. And what we do? We have start at 1, and sorry, this is end at 1, start at 1, plus 1. We have a length 1 comma 2. Which one is smaller? 1. So we'll update it, and yeah, and we'll do the start plus plus, and we'll not go again in this loop because you can see 2 is greater than 1. Yeah, we'll keep on doing it. That's how small dry run is. You can dry run for this for a bigger test case. So let's submit it. I hope this is clear. It took a lot of retakes. Yeah, and let's submit it. Mm, yeah, it is getting submitted, and I hope you did get to learn something in this video. And it takes a lot of effort to make such videos, so consider subscribing, liking this video, and commenting what you feel. And yeah, and if you have any question, you can also comment that. So you have to do what you have to do, so keep grinding, guys. You guys are awesome. See you in the next one. Bye bye.